Okay, today we'll be focusing on how to use your custom dataset with the PyTorch C++ version. So first things first, leave a like if you enjoy these videos. Also subscribe if you want more. Everything you need is also in the repository, so I will leave a link to that in the description. Furthermore, if you have any questions or concerns, leave a comment. If you have any inputs, fork the repository and make a pull request, and we can, if you can do something better than me, then I'll be gladly to, merge it here. So first things first, I already grabbed a data set for you guys. So I grabbed this off of Kaggle. It's just a bunch of cat and dogs images, and that way we can actually, see what's happening in here. So you have a dog image. Also, I've already went through this a couple times. I have this CMake file here. You need to alter this path right here, but everything else should work pretty much the same. So just make sure you alter this path right here to your libtorch, and it's a standard thing as we did before. But that's all. Like I said, link to this repository is in the description, so just go there and grab everything that's needed. Okay guys, so I'm going to show you what I have already set up. So I have my dataset, my CMake file, my build directory, my include directory, and my source. So I'll show you what's in each and every single one of them. So before you start, so make sure you make each one of these folders. You can get this from my GitHub, like I said before. So in our source folder, we can see that we have two files. We have a dataset.cpp and a main file. So make these two files in your source folder. Let's get back out of here. Let's go into our include directory. All we have here is just the dataset.header file, so you can go ahead and make that as well. And as I said, this is in our GitHub repo, so you can see it right here. It's just a bunch of images. So I've already ran the CMake on here, so if you don't know how to do that by now, all you gotta do is go make into the build directory, CMake, and then you can build it. So I've already done this, so I'm not gonna do it again. You can see. And I'll show you my main file, what I have in it right now as well. It's nothing really. All I have is this. So make sure you include torch right now and IOStream, and then we'll add in our data set later. So let's get into it. First things first, let's go into our include. Let's go to our data set header. Now we need a couple things, right? So let's make sure this file only runs once, and let's have our include. So we need IOStream file system to be able for us to traverse through the whole data set. OpenCV, obviously, because we're dealing with images, PyTorch, and then other OpenCV stuff. So let's actually make this easier for our file system. So we'll call this, just so we can reference this a little bit easier. And let's make our class. So we'll use a strut. We'll call it cat dog. And here's the important part: we're inherited from the torch dataset. So class. So all we have to do is torch dataset and datasets. And cat dog, the name of our class, and we can start. So let's make something public, and some private variables. So we need to describe, we'll have basically our test data and our training data. So let's make an enum for that, and we'll call it ktrain, and then we'll have another one called ktest. Let's work on our constructor. It'll take in a string, which is basically where our data set is located, and the mode. So whether we're in train mode or we're in testing. So let's do that. Okay, our constructor's done. We need to override this retrieves the example at an index. So what we'll do, let's override that torch function that's in there already for us. So all it takes in is an index, and we'll override that. We have another function which basically returns the size of the data set. And this one we'll just check. I don't think we'll be using this one, but if you want to use it, you can go ahead. Checks if the training subset, so bool train turns images and labels. This function, tensor images, that to be a constant. Targets, that to be a constant. And basically this just returns images and labels. So in our private variables, we'll need something to hold our images and labels. So we'll just have one called images underscore, and another torch tensor called labels or targets, whatever you want to call it, and one to hold the mode that we're in as well. Alright, so this is all we need in our header file. These are all the functions that we'll sort of be working with. We'll have a few more, but these are, all we need for this class. So let's go into our source, and let's include our data set. Now, let's make a namespace here, and we'll need a couple constants. So I've already done this for you guys, so you guys don't have to do this. So let's, the train size, which is basically how many images are in the training folder. I found this worked. There we go. And same thing for our test folder. And then the size of our image. So you can set this to be whatever you like, but I'm just gonna keep this around 300. So let's do that. And there we go. Now I'm gonna work with a couple things. So we'll have a function here, and this function is responsible for doing what exactly it says. It takes in a image and it turns into a tensor. So CV, OpenCV turns it into a tensor. So it takes in that. We'll be implementing that. We'll take in we have another function in here that will basically return our images and targets. So 2 torch tensors. Call it read data, and obviously takes in the root of where everything is stored. Oops. And it takes in a boolean of train. Okay, so basically I believe this is all we need in here, so we should be good there. And that's the end of our namespace. So 1 second, toggle this to be cleaner. Okay, so we'll come back here. Let's just work on our constructor for now. That's a little easier. So we'll have our cat dog. As I said, it takes in everything on the left. So it's to that root, a reference to the root. And we'll have some membership initialization. So I believe that's the mode underscore. So and yeah. Okay, so we'll call this tensor, this function right here from our namespace, and this will basically return everything that we need. So let's do that. Call it our data, read data, pass in our root, and our mode will say default, set it to train, and I believe from there we can get our images. And then we can get our targets as well. So there we go. This is all we need in our constructor. Let's actually learn how to, let's actually implement the next function, which is basically returns whatever is at that index. So call our get function, size t, index, and it returns basically our images at that index and our targets at that index. And that's it in here. Okay, so we'll implement the other functions later. Let's actually implement these two over here. So first things first, I'm going to send an integer I. This basically just is needed for the training size, so it's reference for that. So int I is equal to 0. Like I said, we're going to iterate through the whole data set, so we only need everything's a JPEG file, so we'll need to know that. We'll have a string to match that. Let's make sure we have the correct number of samples. So if we train the data, then give us k train size, else give us k test size. Also, we need to make sure we're in the right folder. So let me do this as well. For training, root plus the train folder, else root plus the test folder. Simple as that. Now, let's see. Okay. Now let's set up some defaults here. So our targets, let's set up empty tensor, num samples, and set the data type to a long. And we'll do the same thing, targets. We'll do the same thing with our images as well. Set an empty tensor, 3 by k rows by k columns. And let me not make this mistake again. Make sure this is in brackets. Now, an important thing to note when you're dealing with these images. Now, when you want to turn these images back into regular tensors, it becomes a bit of a problem when you're dealing with float 32. So I just kept this at regular k float. So that seemed to work for me for some reason. I don't know, but I just kept it at that data type. So now let's create a vector that holds these folders so we can iterate it through them. So hat folder plus cats And we'll do the same thing for dogs. Dog folder and dogs. And we'll create a vector that we can iterate through, holds strings. Iterates the cat folders and the dog folders. Awesome. So we have that. Now let's iterate through these folders. Reference to F and folders. Basically we'll assign a label to each class. So cats 0, I guess, whatever's 1. The first one, cats is 0, dogs 1, I guess, whatever you want it to be. Then we'll just iterate through our folder. So in order to do that, we'll use our file system function that basically lets us go through each file or folder within the dataset. So we'll do that, and we want to select only the files that are JPEG. So make sure it matches the extension. And basically from here, we just turn this thing, you grab the images and turn them into with OpenCV and turn them into tensors. So we'll do that right now. Have an image, read p.path. Turn it into a tensor. What CV to tensor. We're passing that image. And now from there, we'll just assign that image tensor into that empty one that we had before. And our targets, same thing we had before. Torch tensor, pass in our label, and make sure it's a long, set it to be a long, I guess. And then from there, we want to actually make sure we don't keep going and grabbing random files, so we'll just break it once we reach our number of samples. Oh, my bad. And we'll make sure we increment I, and then outside of that, we'll make sure we increment our label. So this is pretty much all that's needed. Oh, we have to return what we need in here. So we'll just return our images and our targets. So this function is completed. You don't need to add anything else. So we need to work on this here. So once we do that, let's actually resize the images. So because each image in the folder are different sizes, so I want to keep things constant. Taking that image, output the image, set the size. Columns, don't change it. And we'll use CV interlinear as our interpolation. So now you can change the colors if you want. Or apply a color map, if you want to. Whatever is your choice. Image. We'll make sure this is an RGB format. Well, now we'll turn this into a torch tensor. So from blob, we're passing our data image from that CV matrix. Make sure you set the sizes, and we'll save this in bytes. And then we'll shape the tensor so it can fit into this empty one right here. So two, 0, 1. Change the type as well, back into a K float, and then we'll just divide everything by 255. There we go right there. Then we'll just return this. Very simple. I'll go through this once more. Resizing, make sure it's in RGB, then we'll turn it into a tensor, make sure the shape is right, and then put it back into a float, and then divide everything by 255. Obviously you should know by now, if you have an image, it's between 0 and 255, so we just normalize this with this. So from here, we'll go and implement the rest of everything else. So let's do that right now. Everything else is pretty simple. So we'll just return how many images that we're working with in here. That's pretty simple. Check it for training. If I have any errors, I'll come back and fix it. Torch tensor. Just returns all the images, basically. Images in tensor format. And then we'll have one that just returns all the labels as well. Okay. 1 second. Okay, I believe that's everything that we need in here. So now, let's go back into our main file, right? So, if I need to change anything, I'll come back in here. But for now, let's go back into our main file. So now that we're here, we can include our data set. We'll need a function basically to test everything out. So I'm going to call this function CV tensor to CV just to make sure everything comes out correctly. And then we'll implement it down here. Right. Okay, let's set our data set basically. So the location of it, and then we'll set it up right here. So let's call our data set, train data set. So you put the cat dog out, as I said before, it takes in a root. It also takes in the train, but obviously this is our training data set. Then we can map this. Obviously, let's map this and normalize everything. So and set up our mean and standard deviation. So our mean, everything be 0.5, and our standard deviation, same thing. We'll continue to map this. Transform, and we'll stack everything. So here it is a little bit cleaner. I believe that's everything that's needed. Yeah. I'll make sure this is correct as well. Let me go back into the GitHub repo. Okay, this looks better. Okay, so normalize it and then stack everything together. Then we'll have a train loader. Same thing we do in Python. Set the batch size as well, pass in the dataset, and 4. And we'll do the same thing with our test dataset, very similar. I'm just going to copy and paste this pretty much. And the only thing I've added basically was this right here. Make sure the mode cat dog mode ktest is in test mode, and we're passing in our test dataset. So that's all for this. Now, before I continue, I want to actually implement this tensor to CV. So first thing we do is just going to take in the tensor. So we'll just make sure it's in the right shape. That's the first thing we do. So 1, 2, 0. Next thing we'll do is, it's already normalized, so let's unnormalize the image. So multiply by 0.5, add by 0.5, then we'll multiply again by 255, then we'll clamp it between those two numbers, 0 and 255, and then make sure it's in bytes. Next thing, this is contiguous. And then let's get the height and width. Then let's set this back into a CV, open CV matrix, call it output, set the size, width, height, and then it has 3 channels, so 8 UC3, and then from there we'll do a memory copy. X dot pointer data pointer. That's the size of it. Times now, and then just return that output matrix. Okay. Now, this is finished. Let's actually iterate through this data set. So, it's real simple. It's not that hard. We'll get the batch Obviously we set the batch to 4, so we have 4 images and 4 labels. Call the train loader. Our images, batch.data. Our target, or our labels, you can call it whatever you want, batch.target. Now, let's actually use one image to test everything. So 0. Display that image, and then put a wait key on here. And just stop it there. Okay, I don't want to iterate through the whole data set. All I'm going to do is take a sample from the data set, turn it back into an OpenCV image, and we can see what's happening. So I hope this works. If it doesn't, I'll go back and make changes. But let's see what we have here. Okay, we have a couple problems. So in here, get S. Also in here, when we return, oh, also when we iterate through the folder, we have a problem here. And we have a problem here as well. So kbyte. Okay, K test size, we have a couple problems. In a second, guys, I will fix this in a second. Okay, guys, I am back. I fixed a couple errors. I've had a few naming problems in here, so I fixed that. I didn't really change anything in the main function, everything's the same. In here, I missed a semicolon, so make sure you add that. I also named the targets wrong, so make sure you add that underscore at the end. And yeah, I believe that's pretty much it. Make sure everything in here matches as well. Again, you know, go back into the GitHub repo. You can find this code in here and then just fix anything that might look bad. But yeah, everything's in here. Make sure you name the targets variable correctly. I didn't do that before. And I think you should be good to go. So let's run this. And as we run this, everything should come out correctly. And as you can see in a second, it's iterating through the whole data set right now. We have a dog image. So what's happening here, I'm going to explain. We went through the batch, and basically we got this image back after we opened it from the data set, we turned it into a tensor, and now we've turned it back to a OpenCV matrix. So this is pretty much everything you know that I've showed in the past series. Everything here, you can do a lot with it. You know how to make a custom data set. You know how to make a model. You can go ahead and challenge yourself and actually create a model, add a loss function, add an optimizer, and then you can actually train something, and you have a cat dog, I guess, classifier. So if you want to add that, and someone wants to try that out, I'll gladly merge it into the repo, and you can go from there. But this is pretty much it. Wish you guys luck. Again, code's in the repo. Like and subscribe. Thank you.